All right, we're back on. We're up to number 20. Okay, so again, we still have transformations. Now, it's really worthwhile remembering that if you have a quadratic or a parabola in vertex form, then it looks like this, where there's a number in front, x minus h squared plus k, where the vertex is the point h comma k. So opposite sign, same sign. In this case, the vertex is at -6, -2. Opposite sign, same sign. So if we're looking for -6, -2, that's right here. So this is the one we're looking for. 6 units left and 2 units down from the parent function that has its vertex at the origin. So let's keep rocking. We've got another one. The vertex is at the point opposite sign, +9, same sign, +5. So we're looking for +9, +5. That's this one. Okay. Translation 9 units right. 5 units up. Okay. The next one, it only has a multiplier of -1 in front of the x squared. And boy, we have to look back to this. And when there's a negative in front of the function, it's a reflection over the x-axis. And, ooh, that's not what I wanted. And that is, I can't remember where it was, probably here. That's not it. There it is. Reflection over the x-axis looks just like this, so it's the first one. This is the graph is a reflection. I think they say in the x-axis. I should probably have the correct wording. A reflection over the x-axis. Well, that's what I would have said. I thought they had awkward wording. The graph of f. Okay. And then this one, it looks like there's a vertical stretch by a factor of 3, is a graph of G is a I'm just guessing what the pull-down menu says. This is my best guess. But anyway, if it's a vertical stretch, it'll make it thinner. So that's what it does. It makes it thinner. Okay. Identify the vertex. Well, the vertex we know is -2, 1. And there's 3 transformations. The graph of f is a blank. This vertical stretch by a factor of 3. A translation 2 units left. Remember, everything that's horizontal is the opposite of what you think, and 1 unit up of the graph. And the vertex is -2, 1. The graph of G is a vertical stretch by a factor of 4. Oh, so we have to rewrite this. And a reflection over the x-axis followed by a translation up 2 units. So there's a bunch of stuff we have to do. So we have the new function. Vertical stretch by a factor of 4 just puts a 4 in front of it, in front of the whole function, followed by a reflection in the x-axis. And remember, when there's a reflection across the x-axis, that's just a -1 multiplier in front of the whole thing. So it'll be negative 4x squared. Here. Followed by a translation 2 units up. Remember, when it's 2 units up, you look for up, you just need to add 2 to the end, okay? So that, oh, geez, wrong thing. There we go. So let me see, the vertex of the new one, well, the vertex, remember, is opposite sign, same sign. So the same sign is 2, and the number subtracted from x is 0. Since there aren't any parentheses, okay, the vertex and the axis of symmetry. That shouldn't be too hard, right? If we remember opposite sign, same sign, the axis of symmetry, it says right here, is the equation x equals, and then whatever it equals is the x coordinates in the vertex. So if the x coordinate in the vertex is -3, the axis of symmetry is x equals -3. So that's there, and the vertex is -3, 5. And which one goes to the left 3 and 5? It's this one. So opposite sign, same sign. We've got -1, -3. And so the vertex is -1, -3. The axis of symmetry is x equals -1. -1, -3 has to go to the left 1 and down 3. So it's that one. Identify the vertex and the axis of symmetry. Not as easy anymore because it's not in vertex form. We could complete the square to find vertex form. I think the best way, since when we learned this stuff, we didn't know how to complete the square. So the best way to do this is to just graph it. Y equals x squared plus 2x plus 1. Oh, and turn off your plots 1, or else it's not going to graph well. So x squared plus 2x plus 1. When you graph it, make sure I have this right. Yeah, I got it. Looks like the vertex is at -1, 0. So the axis of symmetry is -1, and there's the graph. Okay, you can see that not too hard just to graph it and find the answer. Same thing here, 3x squared minus 6x plus 4. (3x squared minus 6x plus 4). Looks like the vertex is at 1, 1. Like that one? For sure, this one. 1, 1. And this one. The axis of symmetry, remember it's the x coordinate, so x equals 1. We can make sure that that's really the vertex by looking at the table. We're looking for where the numbers, where the numbers start to repeat. It doesn't happen all the way at 7. But 1 was the x coordinate where we thought they repeated, and they do because there's 2 4s, 2 13s, 2 28s, so that worked out. Okay, vertex, x-intercepts. The trick to finding the x-intercepts, you want the values of x that make this whole thing 0. So -3 and +3 are the values of x. -3 makes this one 0, +3 makes that one 0. So if it crosses the x-axis at -3 and +3, and this vertex is there, looks like it's at 0, -9, maybe. We're going to check it. And the axis of symmetry is 0. And the x-intercepts are -3 and +3. Let's graph it and make sure everything's correct. X +3 and x -3. Yeah, and it looks like it really is 0, -9. We can check and make sure by looking at the table, second table. And 0, -9 is where it starts to repeat. So we have all this correct. I think I'll do one more and then we'll go to the next video. I'm not going to. I'll hold this one off for the next video. Okay, so I'll see you in a second.